Hey everyone, welcome back to Cracking the GRE Math Subject Test. This is Calculus 2 and we're on question number 15. Oops. There we go. So in this question, we're told that there's a right circular cylinder. Remember, a right circular cylinder is like a base with that's a circle, and the top is also a circle, and it looks like that. And the radius is r, and the height is h. So in our case, r is 100, and h is also 100 centimeters. And they're asking us which of the following statements best describes the volume of the cylinder, or how the volume of the cylinder will change. In other words, what's going to be if the whole volume is v, what's going to be our dv, like our delta v, if r increases to a little bit, just by 1 centimeter, and h decreases by 1 centimeter. So in this kind of question, when we're asked to approximate a change in a certain quantity, then it's kind of like in Calculus 1, where we use the tangent line as a linear approximation of a function. So here we're going to use the tangent plane. And just remember that if you have a volume is equal to some function of let's say r and h, then the small change in the volume is approximately equal to the partial derivative of f with respect to r times dr plus the partial derivative of f with respect to h times the small change dh. So in our case, our volume, remember, is going to be pi r squared times the height, h. So our partial derivative with respect to r is going to be 2 pi r h, and dr in our case is just 1 centimeter, because we're increasing the radius from 100 to 101. And the partial derivative with respect to h is going to be pi r squared, and h is going to be dh is going to be negative 1, because we're decreasing the height from 100 to 99. So now let's plug in r into h. So we get 2 pi times 100 squared plus pi times 100 squared times negative 1. So actually this is going to be a minus out here. So this simplifies. We can factor out that 100 squared, and 2 pi minus pi is just pi. So that's answer C, because it's a positive, so we're increasing by approximately pi times 100 squared.